My name is Josh Long. Welcome to Enterprise Application Integration and Batch Processing in the Cloud. Try and fit that in a tweet. That's my email. That's my Twitter coordinate. Please take them down. The reason is because I want you to have recourse if you should leave this room more confused than when you came in. And you do now. A little bit about me. We have these brand new slides, and they encourage you to take up all the space. Really explore the space. This is a different ratio than normal slides. And means I get to make that picture as big as I want it, and nobody cares. So my name is Josh. Like I said, I'm the Spring Developer Advocate for Spring Source. This is my email. That's my Twitter coordinate. I've written 4 books now on Spring and various technologies: Spring Integration, Spring Roo, Core Spring, Spring Batch, etc. And working in right now on Cloud Foundry in Action from Manning. I'm also I'm only half joking, but only half. I'm also the leading contributor of bugs to many fine Spring Source projects like Spring Integration, Spring Batch. Work on the activity workflow engine, working on the ACA for Spring Integration. Just generally I'm out there causing trouble. So that's about me. And here today, we're going to talk about sort of there's no one specific superstar for this talk. There's no one specific technology. It's just that we've kind of landed in a very nice position, right? For many years, Spring Integration, Spring Batch, and RabbitMQ and so on have afforded us the flexibility we would need to be able to build really big, really powerful systems. The only thing was we didn't actually have really big, really powerful systems on which to run them, right? So a lot of times we've built out these applications in the same sort of monolithic way that we've thought about other applications previously, right? Well, now we have a new frontier. We have the cloud, guys. We have the ability to scale out. And that's an interesting proposition, right? Because now we have 2 things that are perfectly mated to each other, right? I, personally, think Cloud Foundry is a fine choice, and that's why we're going to use it in for the demos here. A lot of what we're going to talk about today isn't Cloud Foundry specific. It just happens to work really nicely on Cloud Foundry. So let's start off with a little bit about Cloud Foundry. The first feature, we're going to go through a lot of stuff here today, guys. There's an overall arrangement here of integration, batch processing, scaling out, a lot of which we sort of takes, or it's in the same vein as what Adrian covered yesterday in the keynote, so you'll see that. Well, not the same vein, but appreciably similar. So to get started, we need to talk about a few things so that we're all on the same page. How many of you guys have used Cloud Foundry? Okay, good stuff. So you guys know about something called the worker processes? Worker processes are basically a very fabulously silly name for public static void main, right? It's the ability to run a background process, which is the default state of things. When a program is born, when software is born, it is public static void main first, and then it becomes a web app if we bless it so, right? So to have a separate feature for that is a little, I don't know. But anyway, it's called worker processes, and it's a great thing because you can run batch jobs, back-end analytic processes, things like that, on Cloud Foundry. It's not very hard. You can use this blog right there on blog.springsource.org, which I put together to get an idea of how to build Spring-centric public static void main jobs, right? You need to deploy and you need to tell Cloud Foundry about how to configure your worker process. So this blog will tell you how. But basically, once you're done, do yourself a favor, have Cloud Foundry generate what's called a manifest. There's an example of a manifest on the right there. It's an enumeration of all the things your application needs to be able to flourish and run inside of Cloud Foundry. Stuff that once specified is better left, unchanged, unchallenged. It's tedious, right? You don't want to have to do it. So here's an example of a manifest for a public static void main Java application with 512 megs of RAM associated to it and 1 RabbitMQ instance named integration service. This can make it very, very convenient to build these kinds of applications. What we're going to be talking about here is essentially multi-component, like modular architectures, right? And so being able to describe those modules and their arrangement and their topology in one succinct little file, a manifest, if you will, is very convenient. So please take a look at this. You can actually describe multiple modules, and you can describe how they relate to each other. You can say that I need, whenever somebody does VMC push, I want 5 of these modules to get deployed, all at the same time, one before the other, etc. So very, very powerful. Building a Java application that can be run conveniently within one little command line incantation is kind of a pain. So there's a very good plugin for Maven. How many of you are using Maven? Just out of curiosity. Okay, me too. I'm a fan. This plugin, again, it's in the blog. You don't have to scribble this all down right now, but and the slides I'm sure will be online. But this plugin, once configured in your Maven project, will package up all the jars in your application, put them in a directory, package up the main class, add it to the manifest.mf, and you can actually just do Java jar and then the name of the jar, and it'll have the full class path and everything else referenced, which is why this previous manifest will always work, right? Even if you add new jars to the application and so on, you don't have to tell Cloud Foundry about it. You just let it reference that one jar and that one main class, and everything else will work. Okay, so we got that out of the way. I just wanted to bring that up, make sure we're on the same page. Another thing that's very important, very, very powerful, and again, this is very much in line with what we talked about yesterday's keynote, so I won't belabor the point too much. How many of you guys have used RabbitMQ? How many of you guys are going to try it after yesterday's awesome, awesome keynote? Yeah, wasn't that great? Oh, God, that guy just knocked it right out of the park, right? I mean, I think we should wrap that up and because as we're given to doing it VMware, I think we should package it, give it a new name, and just call it vFabric, message queue or something, and see how many people just flock to buy it, and have that tape cassette of that keynote yesterday. Wasn't that great? Even I didn't even know about some of those features. That's crazy. I mean, it was powerful. So RabbitMQ, good for all the classical, useful messaging concerns, right? You have producer, you have a consumer. Producer can send a message to consumer independent of actually knowing where the consumer is. There's a bit of indirection there in the message queue. Helpful. You can do it both ways. So you can actually have request-reply semantics over a message queue, right? So very, very powerful concept. These are not specific or endemic to RabbitMQ, but they're helpful. If you're not a messaging wonk like yours truly, it's helpful to know that you can achieve these things. And I'm sure, as most of you saw yesterday's keynote, you probably have an idea now. But basically, this is the messaging equivalent of RPC. With one caveat, in RPC, it's intrinsically synchronous, right? So you send a message and you synchronously wait for the reply. In this scenario, you can synthesize synchronous, but by default, it's asynchronous. So you don't have to wait for the reply. You don't have the caller doesn't have to block waiting for the response. He can just move on. You have the ability to do bidirectional, right? So you can say, I have a producer, the producer sends a message to the queue sends it to a producer, which then sends it to another queue somewhere else, right? So you have the ability to really spread out, you have the ability to scale and spread out these pieces, and your application doesn't have to know about it, right? It becomes abstract. They just communicate with message buses. Again, the arrangement doesn't matter, right? Here's another example. You can send a message to the queue and have the consumer and the producer respond to it, and he can send it back to the original one, and that can be in turn sent on to a different consumer, right? So there's no requirement here that the producer be the same as the consumer. My favorite, and the one that we saw very, very ably demonstrated yesterday, is what's called the aggressive consumer pattern. Have you guys heard of this? The aggressive consumer pattern, it hails from 30 years of messaging lore, and in particular, you'll see it well described and well enumerated in Gregor Hope and Bobby Wolf's book, The Enterprise Integration Patterns. The basic idea is exactly what we saw yesterday. It's, hey, I've got a workload, and it's concurrent, right? It's parallelizable. It's easily parallelizable. There's no intrinsic sequences to the way I have to process it. If I have 10 people on a conveyor belt in a factory, wrapping candy like in that I Love Lucy episode, that's fine. If you add more people, more candy gets wrapped. And a lot of jobs fall into that domain. As long as you have a job that works like that, this is for you, right? This is an easy, cheap way of scaling out. And if I have my druthers, I will try and spend time to find a way to make an application that has that quality. I want applications that are easily scalable. So aggressive consumer pattern. The basic idea, I've got work, it's coming down from a central place. I will add more people to the job, or I will add more agents or processes. So as we saw yesterday, store and forwarding of messages, a basic responsibility of message queues. You can send a message, and that message queue acts as a buffer. It protects you against interruptions in the app. No disturbances in the force will ruin your application, right? Because as soon as the node comes back up online, the message queue forwards the message, and the consumer receives the message. Spikes of activity, again, amazingly well demonstrated yesterday's keynote. We saw Adrian demonstrate multi-data center aware applications, sending a message to one and then having an alternate switch, for example, or having the aggressive consumer pattern kick in to absorb extra load, the auto scaler. That was amazing. And of course, we actually have a very unique thing with RabbitMQ, not with JMS. This is very specific to AMQP. Because RabbitMQ and AMQP in particular has an idea of routing, right? In JMS, we'll talk about this in a bit, but in JMS you have a very direct connection between the destination to which a message is sent and the destination from which it's received. There's no way to decouple them. In RabbitMQ and AMQP, you can route based on message properties. So for example, yesterday Adrian referred to what is called the exchange key. And that key is basically just the header value in a message. It's a special header value that the system reads and acts upon appropriately, right? So this is a very useful, powerful case. So, okay. So the obvious question, how many of you guys have used JMS? Me too. It's not that bad. I gets the job done, I guess. But it really could be better. We've just all been lulled into the sense of, this works, why change it, right? It is the 80% case. Well, not 80%. It's enough, is my point, that it has remained relatively stagnant. We'll see some slight upgrades in the new JMS 2.0, but basically it hasn't changed much since JMS 1.1 back in 2000. So that's one point. So AMQP and JMS, right? JMS, of course, is an API. That's very important. So if you change your JMS broker, then your client, typically, most brokers, will need to be updated. Your jar that you're using to connect to that broker. Because it's an API. It may have its own proprietary wire protocol, and that wire protocol may be agnostic of updates, but typically this is not true. Typically, it has a very, very tight coupling, so you get what are called flag day upgrades. You update the broker, suddenly all your applications need to be upgraded to work accordingly. Especially if you upgrade, larger 1.0 versions or, version 1x versions, Whereas AMQP, of course, which was not really, we didn't really spend a lot of time rehashing this bit, but AMQP is a protocol like HTTP or SSH. You can conceivably, I don't recommend it, but you could conceivably send AMQP messages from curl, right? And because it is a protocol, you have the ability to interop in systems not written in Java, right? You can actually send messages from C, C++, Erlang, Go, Perl, PHP, Python, Ruby, everything, right? So it doesn't matter what your use case is. RabbitMQ is probably got a client for it. I mean, it's got clients for languages I haven't even heard of, It's absurd. And you'll do well to check out rabbitmq.org and see the list of clients there. RabbitMQ and AMQP in particular were born out of the financial services industry. I think it's JP Morgan Chase, but I always get it confused with somebody else, so it might be that or it might be somebody else. But it's JP Morgan Chase that originally proffered this use case. They said, we are a bank. While we like Java, we really can't afford to invest the future and bet the whole farm on an API. We need to be able to say that this is a technology that will endure, whether we have .NET or Java or C or whatever, right? So that's interesting, right? This is born of people. This is born of finance, and this is born of people who actually have problems to solve as opposed to message queues to sell you, right? They're not trying to sell you a message queue. They're not trying to add a checkbox to their broker compatibility list. They're just trying to solve a really, really hard problem. Interoperability from client libraries is, ubiquitous. One client library works with all AMQP compatible brokers. So if you get a client library that you like, no need to change, right? Whereas with JMS, interoperability, it's not so much, right? You have specific features that are unique to each client library and for each API, so it becomes kind of a nightmare. Resources can be managed by clients, which is to say that AMQP fully describes all the attributes of the broker itself in the API itself, in the protocol. So all the administrative tasks as well as the actual runtime tasks that you want to do, for example, defining new destinations or exchanges, defining new queues and all that stuff that you would normally do from a central command line or web page console inside of JMS Broker, you can do from the API programmatically. In fact, we saw that yesterday. Adrian, at several points, used the RabbitMQ Spring namespace to define destinations, right? You could also define it in the broker if you like, but you don't have to. That's a beautiful thing. Having said that, AMQP is not yet... Oh, question?
How does the broadcasting system work with AMQP, or I should say implementations of? I'm guessing RabbitMQ is an implementation of.
Yeah.
So when you broadcast it to multiple consumers,
Yeah.
do you guys use a multicast?
I don't know what the networking layer is underneath, actually. I know that... Oh,
How do you say go to 10 consumers, or how do you say go to...
So the consumers are going to connect to the broker. So as long as you add more consumers, they're going to reach out and say, hey, broker, I want to, send me messages.
So there's a particular... I trust that you have to publish and let your consumers know that to go and talk to them, or...
Yes. Well, in the classic case, yes. Although, if I'm honest, again, I saw that amazing keynote yesterday. I'm starting to think that I wonder, and haven't checked because these are features of RabbitMQ 3.0, which is as yet unreleased. But I'm starting to think you have more abstract ways of describing destinations. So you can describe a cluster. You can actually, I think there might be multicast, like cluster-aware connections, so that it tries different ones. I don't know, but by default, yes, you connect to a known place, and that is your only shared secret, right? Thank you. And it's very common to actually connect to a broker, try and get a connection, nothing happens, retry and connect to another one by yourself, right? That's no big deal. Okay. So, where were we? Oh yeah, so AMQP, ubiquitous in enterprise, not so much. Ubiquitous in the cloud, very much so actually. Ubiquitous to a point I hadn't realized until I actually started taking a look around. So for example, on Amazon Web Services, they feature a broker, a queuing technology called SQS. If you like to pay a lot of money and send messages very slowly, it's an option. It's a good one. It's a good option. However, as it is based on REST, which doesn't support really pub/sub style communication, it is very much RPC. If you by default you make a request, you wait for the reply. It's kind of awkward. And it's kind of expensive too. So RabbitMQ is the most widely used message queue on Amazon, despite the fact that they have an API that they would have you use instead, right? It's the natural choice for cloud environments, of course, where you have polyglot, right? So a lot of different clouds, and not just Cloud Foundry, feature RabbitMQ because it works so darn well with all these other languages, So good. So anyway, AMQP, flexible patterns, basically, because it has routing, whereas JMS has just basic producer-consumer and pub/sub, right? Point-to-point and multicast. So designed for large numbers of queues and exchanges, that's another important point. AMQP is very, very cheap. It takes almost nothing to create a new queue. And they encourage you to create new queues as you need, right? It's an anti-pattern in JMS to create an anonymous queue for request-reply semantics, right? If you want to say, I'm going to send a message and wait for the reply, it's possible, and you'll see it done, but it's probably ill-advised to create a queue and say, hey, send the reply to this private queue that I'm keeping in my pocket. Nobody else will get it. That's how I know that this reply is meant for me. Whereas in AMQP, why wouldn't you do that? No problem at all. It's very, 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 very cheap. Okay. I talked a little bit about that indirection. Here it is kind of, wow, that is awkward. Whew. Close your eyes. Ignore the man behind the curtain. Oh, come on, you poor slide. Did I mention we had to resize our slides? Awkward. Oh, that's so much better. Nothing ruins it Worse than a bad diagram. Okay. So this is JMS. This is the topology you might expect from a typical broker because you've been using JMS, which is fine. This is what it looks like, right? You have a producer. Producer sends a message to the message broker. There is no indirection at the message broker level, as I've articulated. So a queue is javax.jms.destination is everything. It is the be-all, end-all of messaging. And consumers consume from a queue, and producers send to a queue or destination, right? There are two subclasses of javax.jms.destination. There's one for queue and there's one for topic. When you send something to a topic, multiple consumers can receive the message from the same destination, right, from the same topic, whereas a queue is distinctly point-to-point. You send one message, one person consumes it, and the message is expunged from the system, but, you know, in the 80% case. So, yeah, not so bad. It's worked, but it's not really as what we deserve. It's the message queue that we have, not the one we deserve. Spring has, of course, for you know, as long as there's been Spring, supported JMS. In fact, it's one of the many fine reasons that people move to Spring and Exodus, you know, in flocks initially, right? Because we made JMS not hurt. So here's an example, right? Here's a simple class. I've injected a reference to a JMS template. The JMS template itself is a Spring class that provides very convenient options, one-liners, for doing a lot of the things that are very, very painful, like sending and receiving messages with JMS. JMS itself is rather verbose, so in order to do anything, you need to set up a connection, you need to set up a session, you need to set up a publisher or consumer, and then from there you need to also say, you know, you need to handle the error handling and the rollbacks and all that stuff based on error handling. And along with all that other logic, you need to do the right thing for rollbacks, transactions, local, you know, JMS message local transactions, right? So it can be quite tedious. So to be able to say just JMS template.send, it just feels better. It's much nicer. So here's an example where we're actually injecting the JMS template, and we're saying, I want you to send a message to the example.q destination, and here's my message. In this case, it's a string. The payload of this message is going to be a string. We're not going to bother converting it into a javax.jms.message. No need at all, right? It's already, we'll let Spring convert it. We'll let it wrap our string here as a payload and then create a message and then wrap it for us. So very, very powerful. Oh, killing me. Bloody slides. Okay, well, so I think I got the wrong ones there. Oh. Okay. So this, I hope, illustrates that flexibility I was hammering home earlier, that little bit of indirection that makes it all work, right? So here's an AMQP setup, right? You have a producer. The producer sends a message to something called an exchange. The exchange is where the magic happens, right? We saw that very ably described yesterday in the keynote. The exchange is pluggable. That's the first thing. So we saw the alternate exchange yesterday. We saw the direct exchange. We saw fan-out exchanges. We saw lots of them described. The important point is that it's also pluggable, so you could theoretically provide your own. In fact, he did provide his own. He actually talked about one called the shovel yesterday, which is an exchange that's a proxy. It, in turn, forwards messages to other brokers, right? It's a mover. It's a mover and a shaker. And the point is, by using that little bit of indirection, you have a nice place to do this kind of stuff, right? So a lot of people have built very interesting solutions by simply plugging in versatile types of exchanges, right? And you could solve any kind of use case you want if you really wanted to. You know, if you're brave enough, you could roll up your sleeves and write an Erlang plugin and write an exchange. I'm not saying you should. There are better ways, but that's a nice feature, right? Is if you really want that routing logic to be centralized, you can put it in the broker, and that gives you a lot of functionality. Out of the box, however, we've already got a lot of functionality, so there's very often no need to write your own. So here we go. So you send a message to the exchange. The exchange, based on some sort of criteria that is entirely unique to that exchange, forwards the message to the queue inside the message broker, and then the consumer of that queue gets the messages. So there's no correlation between what you send a message to and what you receive it from. Very important. That gives you a lot of flexibility. And by the way, you can say, hey, I want to send a message to a queue. And just as a convenience and convention, I want it to be received on that same destination by the consumer. But so you can mimic JMS, of course. It doesn't have to be more verbose, but it's just nice that you don't need to. So I mentioned the topic problem. I mentioned some of the problems with JMS and anonymous queues. Another problem is a topic explosion, what I like to call topic explosion. So messages with fine-grained routing, market data, gambling, things like that. Anything where you have a lot of categories into which a message could be sent, or imagine a lot of buckets. Each queue is a bucket, and you have to sift through lots of data, and they have to be separated out. It's bad. You don't want to do that in JMS. JMS hates that. It hates it. It makes it sad, and when it's sad, you suffer. It becomes nightmarishly expensive. That's the first thing. You're not really supposed to do that, This is, as I said, very cheap at AMQP. In fact, we are encouraged to do that. It's very cheap to use your message queue as the buckets. AMQP, here's an example. Here's the Spring AMQP API that you can use to actually send messages and receive messages. Again, doesn't really look all that different. Notice that we didn't, contrary to the deceptive simplicity of this slide, actually try and enforce the same API across JMS and AMQP. There's no point, right? You'd be losing features. So having said that, this is convenient. This is not bad at all. Here's an AMQP template. We're saying convert and send. My exchange is the name of the exchange. The second parameter there is the routing key. Okay, that's the key that I was mentioning that the exchange will look at and use in routing the messages to the right destination, the right queue. And otherwise, it's doing the same thing. It's wrapping up the string as a payload, adding some headers, and forwarding it on. It's going to add one header in particular, which is the router key. So messages, map of keys and values, and then the payload. Spring AMQP itself is well supported by both Java and .NET. We have people working on it all the time. We have the support for core AMQP, and then we have specific APIs that work very well with RabbitMQ in particular, take advantage of some of the proprietary features, and that's fine. Good to take advantage of a powerful technology, but you don't have to. All right. So by default, we have the AMQP template, and then the subclass, the Rabbit template, which is the one I typically use. How many of you have used the message listener container apparatus inside of Core Spring for JMS? Basically, the message listener container is... Do you guys remember EJBs? I wonder sometimes. Do you guys remember message-driven beans? Okay. So the idea is very simple, right? I have this class, and it's going to sit there and process messages as quick as it possibly can, right? And it has to get those messages. Typically, you set up a session, and the session, it's event-driven. You just say, I won't... You call me, I won't call you, right? So the message queue will deliver a message, and as soon as that message is delivered, your method gets invoked, and you get a chance to respond. Well, that's done by something called the message listener container. Spring made that POJO, so you don't need a message-driven EJB, which, the world over rejoiced. So we have a message listener container for AMQP. We have one for JMS. It's very powerful. You can say, here's my bean, here's my method, call it when a message comes in. I don't want to know anything else about JMS. I can write my message listener container. I can configure it and configure my POJO entirely independent of any messaging concerns. In fact, I can write a message listener container POJO with a method that takes the payload of my message. It doesn't even have to have any class. I don't have to have a message or anything like that. And we use that message listener container for both the inbound JMS and inbound AMQP adapters inside of the Core Spring integration project. So you'll see it's very fast there as well. Okay, so here's how you would do it. Here's how you would read a message incorrectly, right? Here's how we're saying synchronously. I want to be able to connect to this queue, and I want to consume a message synchronously. Basically, that'll block when you get to that line, right? But you can do it if you want. The message listener container is ideal. That's the way you should do it. Message listener container, configuring it looks like this. Here's the AMQP version. I configure a listener container. I give it a pointer or a reference to the connection factory bean, and I say, here's my handler, here's my method, and here's the queue I want to connect to. Just call it, right? This is what I was talking about before. Oh, important point. Even though your Java code, or Groovy or Scala code or whatever, is dead simple. It's just a method. It's just a method inside of a class that receives an object. You still get all the features you want. You still get retry, and rollback, and all that stuff. You can still say that I want 10 threads consuming messages from this destination, and I'll go ahead and route them to this this POJO, right? So you can configure all that inside of the message listener container apparatus. You don't have to worry about that in your code. Okay, so where are we, right? We've said this before. It's important to reiterate this and reframe this, just because I think it's so powerful, and it's key to a lot of what we're going to talk about, not just today in this talk, but going forward, right? The new architecture is decoupled, right? It's the name of the game. So messaging, and in particular RabbitMQ, offers you lots of decoupling, all the decouples, right? So you get spatial decoupling, right? You could say, I don't care about where you are, I just want to send a message. You get temporal decoupling, which is to say, I don't care if you're still there, I don't care if you're there when I send my message in time, right? In this point of time, I don't care if you receive it right now. Just get back to me when you can. You get logical decoupling, which is to say that sending it to an abstract destination on the broker doesn't necessarily mean that it's being consumed by the same abstract, by some consumer on the same abstract destination. This promotes flexibility, resilience, performance, scale, blah, blah, blah. We'll see that driven home in a bit here. As I said, and this is also important, RabbitMQ is not the first, I think it's the best, but it's not the first cloud scale messaging. This is the first cloud scale messaging, and I challenge anybody to prove otherwise. On Cloud Foundry, it's very easy to use RabbitMQ, right? Let's see. You can go to your command line. I hope you all can see that. Let's see. You can say VMC services, and you can enumerate. You can see here I've got RabbitMQ enumerated among the different types of services available to me. Very easy to create it, very easy to bind it and associate it with any kind of application. So you don't really need to spend time worrying about setting up the infrastructure and the middleware. That's convenient as well, right? That's the beautiful thing about this. If you have any concerns about this, just use Cloud Foundry. You'll get to skip all the icky bits and just get going. I'm not going to lie to you. Setting up RabbitMQ from whole cloth is kind of painful. And if you run into errors, you run into Erlang errors, which is double trouble or double the fun, depending on whether you're a masochist or not. Okay, so that's RabbitMQ. I just wanted to make sure we're on the same page. You got a kind of an idea of the arrangement of APIs and technologies and so on. Now let's look at batch processing in the cloud, right? How many of you have used Spring Batch? Oh, guys, you're in the right room. I'm a fan. I love Spring Batch. Yeah, Spring Batch for the win. Spring Batch, before we can talk about it, it's important to talk about why we're here, why we should care about Spring Batch. I think no article and no story better drives home the point than this particular article from Computer Weekly, May 2000. It describes the tragic situation of the Department of Social Security in the UK that suffered from two major IT failures, and the second failure was due to a overpayment of 112,000 claimants on Social Security due to an error in the batch processing logic. Now I know, guys, I know what you guys are thinking. I understand, so what's the problem, right? I mean, more people got more extra money, yay. But still, it represents a fundamental problem. We can't afford to have batch processing go awry, specifically because if you do it wrong in the micro, it gets really, really, really bad in the macro sense, right? In the big scheme of things. Batch processing is very delicate, but it's also very important. It's everywhere, right? Just show of hands, and you're among friends here, guys. You're among friends. How many of you guys have ever written some sort of process that read something from a file system and then loaded it into a database? In college, you tried it. We all tried it once in college. Come on. Don't lie. We've all done it. Cron or something like that. These are batch processes, right? It's disgusting, horrible, grueling work, and you shouldn't have to do it yourself, but we all have because there's no, up until now, there hasn't been really a conventional way of doing it, right? And batch processing, to make matters worse, sort of reinvents itself every decade, right? So we had COBOL, and we still have COBOL and Kix, actually. I mean, we'll get to that in a second, but you have COBOL and Kix in the, starting in the 60s and 70s, and then you had Unix, right? By the time you got to the 80s, we had Unix and C batch jobs and so on. And then, of course, in the 90s, Java and C++ and all these guys, DCOM, we started doing batch jobs there. So we seem to reinvent this particular wheel every decade, and there's a reason. It's a very important thing to solve. I mentioned COBOL and Kix. How many of you have had the great pleasure of using COBOL and Kix? It's not good. I'll tell you guys a dirty little secret. I've consulted for a lot of banks, a lot of financial service companies. You go to the first floor of most of these banks, most of these companies, and you find the young, enthusiastic sort of Java developers, the people like us, happy and fancy-free, and then you go to the floor above, and you have the older, more distinguished, neck-bearded types, right? And the dirty little secret is that even though they haven't showered, they still make more money than we do. And there's a reason, because these guys are doing COBOL. These guys are the ones that control the batch jobs, that control the empire. They have the keys to everything. This is a very important thing to get right, and they are willing to pay through the nose to get it right, right? So batch processing, big problem, big data, big everything. We need to solve it simply. Spring Batch solves this problem. It makes it very, very easy. When you work with Spring Batch, conceptually, you're working with a job. You describe a job in Spring configuration using the job description language. The job itself is composed of multiple steps. When you launch an instance of a job, you get what's called a job instance. When you want to ask the job instance about how the job is doing, you can ask it for a pointer to its job execution. When you want to find out about the execution of a particular step of a job, you can ask for a reference to its step execution. And interesting point, this is not something I normally have to talk about, but now that we actually have it, it's worth mentioning. Wayne Lund, one of the core Spring Batch co-founders and all-around great guy who's here at this very conference, and if you have a minute, you should accost him and buy him a beer, has taken Spring Batch and its game-changing API and its leadership, and it has been more or less created, converted into the standard. So there's actually JSR 352 in this case. They're trying to standardize batch processing on Java. That API looks like this. It is this, basically. So it's very cool. I mean, learning Spring Batch is good not just for this, but because, it represents the future, not just for Spring, but for everybody in the Java JVM community. So yeah, looks like that, right? The operator, that's you and me, implements the job and the steps, and he actually, wires that together. He can wire that together. Each step itself has typically an input and an output. So very, very simple, very much like a Unixy type pipes scenario where you have input coming in and you forward the output somewhere. There are concerns at play that you can take advantage of. For example, handling exceptions, handling retries, and so on. And by the way, when you have a step, you can take input, you can optionally process it and send it to the output, right? So this input, this is an arrangement you can tailor however you like. We have lots of different item readers and item writers that come with Spring Batch, right? So, you don't have to write your own. We'll look at that in a second. But if you were so inclined to write your own item reader, for example, here's the contract. You're going to read one T. It might be one row from a file. Might be one record from a database. It might be one, a message from a JMS broker or something like that. It might be one XML element from a large streaming XML file, whatever, right? But that's how you're going to read it. And if you want to build your own interoperability with some other system, you satisfy that criteria there. Once T is returned, you can optionally provide it to a processor. The processor's job is to, probably where you're going to write your own logic. This is probably where you're going to probably inject your code. You're going to say, I want to be able to take all the files that I've read and then, have them convert to a POJO, and then in this object, in this processor, I can say, oh, for every product that I've read in from the database, go ahead and update the price to be, 200% more expensive because it's Christmas, right? I know, kidding. And then you forward that changed object onto the writer, right? So you want to commit that change back to the original source system, right? So here the item processor gets the input, which is the original product, and the responsibility of this item processor in this case is to update the data and then send the resultant data as a return value, which will be forwarded on to the writer, right? And this is where the batch processing comes in. This is where it gets so very, very, very tedious. Writing is what costs so much money. This is where all the error is happening. So you don't want to write this code yourself. You want to let Spring Batch's writers do the work for you. It's going to work in terms of a chunk. You can configure how many chunks you want. You can say, I've got 5 elements in my collection. I've got 1,000. I want to be able to commit 1,000 at a time. This is important because you don't want to go through a large file with 10 records and then commit 10 and then have that same logic try and commit 100,000 records on the next file. You need to say, 100 at a time, 1,000 at a time, 10,000 at a time, whatever you're comfortable with in one transaction. So the contract here is whatever configured chunk size you've got, it'll give you a list of that size or less, right? A list of that size or less. So you can say, I want to receive 100,000 or 10,000 input objects, and I'll go ahead and write that out. Again, you're not going to write this code yourself. It's just nice to know about this contract, right? Conveniently, in both cases, the exception handling has been taken away from you. You just declare throws exception, and the framework will handle the retries and the error handling and all that stuff. So altogether, here's what a job looks like, right? Here's a Spring Batch job. Very, very simple job, but it's a job. So you're saying I've got a job. Its name is skip job, and it has one step. You can have multiple steps, remember. And then this step has a tasklet, and the tasklet has a chunk, and the chunk, in turn, has pointers to a reader, a processor, and a writer, along with some extra information about how often we should commit and how many records we should skip while still continuing. For example, if you read a file in, and the file has bad CSV data, you don't want to have to throw away the whole job just because 10 records are bad. So here you can say, I want to skip. If 10 are bad, keep going. It's not failed. I don't want to abort the job. I'd rather just continue, take note of the errors, and I'll let the operator look at those failed records tomorrow morning when he gets back and has had his coffee and he's in a good mood, by 2 p.m. So that's good. You also have routing here. Again, you have the ability to describe sort of workflow-ish type scenarios. So here I've got a step. The step can be routed on, it gets forwarded on to the next guy. So in this case, we have workflow type handling. We can say, based on the output of step 1, forward to step 2, unless the output was completed with skips, in which case, fail. Go to error print. Or if it failed, then just fail altogether. Fail the whole thing, right? So you can customize this kind of stuff. And you can do some pretty complex stuff. You can say, here's I want to run this step along 10 threads. Or, as we'll see, you can do even more interesting things. So before I get too deep into that, let's see. I want to make sure we're all on the same page here. Let's see. Hello. Navigate. Open type. I did that. Shift Command T. Okay, so there's an item reader. We're going to look at the contract here. So here's some of the other implementations of the item reader contract, right? You've got, I don't know, what is that? You've got a lot. You've got a lot of different item readers there, right? So this is why when I say you don't need to write this stuff yourself, please don't write it yourself. It's done, right? This is the part where you get into trouble, is when you try and write this stuff yourself. This is all stuff that's been tested. It's been used in industry and enterprise for, what is it now, 6 years, 7 years? It's at the heart of many, many large banks. This stuff is stuff that has helped trillions of dollars get moved. So we know it works at scale. We know it works well. You don't need to rewrite or reinvent this stuff. This is why you can save a lot of time just by letting somebody else do this painful stuff, including horrible things like Hibernate. Please, you can, just because we have the class, doesn't mean you should. You can use Hibernate for batch processing, but please don't, or an angel will die, or something. I mean, it's just bad. Don't do that. It hurts. It's so against the way that Hibernate wants to do it. I have seen so many bug requests and so many forum tickets based on that one little thing. If you use it within the confines of how this thing expects it to work, it'll work. But batch processing is not Hibernate. Batch processing is cursors and stored procedures and things like that. It's kind of ugly, but it's the way the world works, and we can optimize for that. We have support here for streaming XML, so stacks, right? We have support for JMS. We have support for files and JDBC and IBETAs and stored procedures and cursors and flat files as well. I mean, everything. Anything you can imagine, there's probably an implementation out there. Likewise, we have, item writer. Similarly impressive list, right? So you can see we've got item writers for hybrid. We got the reciprocal objects here, right? So yeah, not bad. In fact, we even have one for sending email. I didn't know that. Good stuff. Huh. So good. Okay, back to the regular scheduled presentation. I mentioned that you can do some interesting things with steps, which gets us to the sort of crest of this particular section. Steps themselves can be proxies for other things. So you might send a job into a step, and then that step forwards execution state, for example, to another machine or to another thread, right? This is called partitioning. You have remote chunking. So what you're saying here is I want a job, I have a step, it gets to one step, that step is just a proxy step. It's not really a step. It's just a proxy. So it'll send it to some other machine, and that other machine can then consume those records. This gets you a very, very powerful form of MapReduce, if we think about it, right? So you send a message to that step, the step sends the work over to some other cluster, right? The communication between this step and the cluster can be done by whatever you want. And by default, we have support for Spring integration channels. Spring integration channels themselves can talk to everything under the sun. You could theoretically do batch processing entirely on the backs of Twitter, if you wanted. I don't recommend it, but you could. Or JMS, or AMQP, or something substantially more useful. But my point is you could support whatever you wanted to, right? You plug in a channel and plug in the right adapter, and it works. There's also some very good examples of using AMQP. You can use the AMQP support inside of Spring integration by default. That's fine. Or you can use the specific support by this blog, which has they have contributed a more advanced version that saves you from having to look up certain objects and having to configure certain things. So if you get a chance, check out these slides and then check out that link. I don't expect you to have time to write the whole thing down now, but it's pretty useful. Unless you actually want to write it down now. I'll wait. Ready? 5, 4, 3, 2. Boom. Okay. So this process of remote chunking, of partitioning, is also pluggable, right? You can, again, I don't recommend it, but you could theoretically provide your own bits. You could provide your own strategy here. Again, that's the power of Spring, right? It's a framework that you can override in all the ways you want to. So here's an example of some of the implementations you need. You need these guys. Here's an example of one particular version of that AMQP support inside of Spring Batch Admin. Okay. Before we move on, let's look at my first thing here. Okay. So for those of you who want to follow along at home, github.com, let's see, what am I doing? Cloud Foundry, samples. Oh, look at that. That's not even mine. That's cool. Oh, that is so good. Check that one out as well. In fact, I will too, but we can't do it right now. Workers. Here you go. Stock workers. This is the code that we're going to look at today. It's also the code that was well documented and well demonstrated inside of the blog that I listed earlier, which is blog.springsource.org, and it's the just look for my ugly mug. It's batch process. It's worker processes on Cloud Foundry. It's on the Spring Source blog. Okay, and you're more than welcome to take a look at this code at your leisure, and we're going to look at it today. So brace yourself. So okay, here's the code. It's a simple batch job. I've it's a public static void main, first of all. That's the first thing you should be aware of. Can you guys all see that code in the far-off rafters over there? Yes? No? Okay, let's fix it. Let's see. Okay. Mr. Phone Call from Texas, I'll worry about you later. As we're going along, by the way, don't hesitate to ask questions if you have them. I have questions. Why are we here? What's it all mean? Let's see.
We were at the talk yesterday, and I believe it was Oleg's talk on Spring integration. He was using Spring Batch to do.
Hadoop?
Yeah.
Yeah. Isn't that awesome?
I was wondering what your thoughts were on. You mentioned you could use Spring Batch for MapReduce sort of feature.
Yep. So, I don't know if you've used Hadoop. It really hurts. Hadoop is so painful. Did you see his talk? It was like 150 lines of Hadoop code. Granted, he wasn't using Spring for Hadoop. Spring for Hadoop makes it a little bit simpler, but it's still so painful. So if you're going to use it, go ahead and use it. That's okay. You're within your rights. There are some very, very valid use cases for which Hadoop is more appropriate. I just would hazard that for the 80% case, it's not. Right? When I've worked on Hadoop, when I've worked in jobs that and in engagements that required Hadoop, it was like, okay, well, if you don't get up to 100 nodes, then you're really not getting any value out of it. You know, if you don't get up to 100 nodes and really, really have a lot of redundancy and have a lot of, you know, you end up having to call Cloudera, and they're the ones that can make it work. But that's expensive, and so it's not a panacea. It's not going to be a be-all thing. The opportunities there are for the really, really, really big data. They're not for the medium-scale data and for the small data, which most batch jobs up into the hundreds of millions, they still fall short of what I'm talking about when you talk about Hadoop scale, right? So unless you've got hundreds of millions and millions and millions of objects to worry about, you could probably get by some other way, right? And people do. Just ask the banks. I mean, they may not be doing very well with the money, but man, their technology is rock solid. Rock solid. Don't worry. The banks have figured out how to save the money that they do keep and how to process it. So, in the back, can you guys see this? Yes, no, maybe? Good. So first thing first, entry point, public static void main, nothing particularly special, nothing up my sleeves. I've created an application context, right? I'm actually being a little redundant. I'm being a little redundant here for posterity's sakes, but this is just an application context. It's a subclass. It's the Java configuration aware version. And I've said I want to go ahead and activate my profile. So I'm going to activate the profile by getting the context and getting the environment and setting the active profile based on whether this condition is true. So if it's Cloud Foundry, go ahead and say it's cloud. Otherwise, you know, tag it with a local profile. You guys saw this in Adrian's talk. He used a system property. Same thing, right? Same idea. -d spring.active.profiles, and then set cloud or local. And then I tell it to scan all the configuration and Spring components that are in this class, in this package rather, in the package that this class lives in, because all my Spring beans are there. So why bother wiring them up myself when I can just have Spring scan and you know, sweep them up for me? And I'm using the Cloud Environment API that Adrian mentioned to make that test. So if I run this application locally, it works just fine. If I run it inside of Cloud Foundry, it works just fine because it has two different definitions for the data sources and all those other bits. So let's take a look at that. You need to set up batch. Right? Batch itself requires infrastructure pieces. You need to set up a data source. You need to set up other things like that. You need to set up your jobs. So I'm not going to lie to you. It's going to be a little painful to do it. So let's see. I've got my local version here. I've got a data source. This is going to connect to H2 in my local database, you know, in memory. No problem. You can use Postgres if you like. And then in the cloud, I've got a different version. I've got a configuration class, again, with @profile cloud. And because I want to be able to inject a pointer to this configuration class, I need a common base type, so I extracted out an interface, and I can just go ahead and say @inject @data source configuration. And then from there, I can ask it for the data source. I can call, you know, @data source. I can call data source configuration.data source, and I'll get the pointer back. And it'll be the right one. It'll be the cloud or the local one based on the active scope. So here I'm using the data source. This data source is provisioned by Cloud Foundry. So here I'm saying cloud environment. I want to know about all the RDBMSs, all the relational databases that are available to me. Go ahead and tell me about them. Give me a collection. I assert that there is at least one because I need one, and otherwise I should fail. And then I grab a pointer to that first one, and I use what's called an RWMS service creator to inflate. I like to call it inflate. I don't know what the right word is. Nobody tells me these things. To inflate a pointer to the data source, the object that I need. There are similar corresponding objects that you can use for MongoDB, for Redis, for whatever, right? So this is just the RDBMS case. But this gives you a lot of power, because remember, Cloud Foundry reserves the right, as do all clouds, by the by. Cloud Foundry reserves the right to move your database from one IP or a port or whatever. You don't. There's no idea of where your database is located. So you ask, by using this API, you're asking the cloud to give you the information so you can connect to it, right? And in fact, it'll do you one better. It'll give you a fully inflated, fully ready to use, fully connection pooled and everything pointer to a data source. That's all that Spring needs, after all, is a pointer to a data source. So just give it one, right? Let's see. So I'm creating a batch configuration, and I've injected a pointer to that configuration class that was profiled, right? So I'm going to say I want a reference to that class, and whenever it comes in, I want to be able to access the data source. You can then actually set up the other stuff you need, right? So the first thing I need is I need to set up a class that handles the analysis of stock data, right? So this is a simple job, and it runs using that scheduled annotation every 10 seconds, right? Common thing. And it in turn launches Spring Batch. So I have job parameters. The job parameters are Spring Batch concept, right? The job parameters, it's basically a glorified map. It's a type-aware map for parameters. You add these parameters to the job map, and then you use the job execution here to go ahead and run the job launcher rather, to run the job, right? And we've injected the reference to the job launcher, which we'll look at in a minute. And then the job launcher gives you a pointer back to the job execution, which you can then interrogate for information about the status of the batch. Remember, this might block. You can set up a task executor so that when you call job launcher.run, it delegates to a thread pool. So then, in which case, it doesn't block. And this makes it appropriate for launching jobs from a web application, for example, because you wouldn't want a web application or a Spring MVC controller where you hit an endpoint and then you launched a batch job and the batch job ran for a week, right? You don't want your web request polling on that. So good. So and then when you're done, you can say, hey, how'd things go? If it's still running, sleep. And then when you're done, you get the status, the exit code, all that, and you can say, give me information about the job instance and the ID and all that stuff. So okay, that's my little container class. It's the one that's going to control everything here. Let's see, going back here.
Quick question.
Yeah.
So I noticed,
You can even have a slow one.
do you have cloud environment?
Yeah,
In 2 different configuration classes?
probably.
Is that a problem?
No. Why would it be? Cloud environment's cheap. You can.
Well, I mean, you're returning the new cloud environment. Will it just set from one?
Oh, yeah. You're right. I could have actually shared it. I didn't even. I'm sorry. It's basically cloud environment is a nice type-safe API around environment variables. So you could get access to vcap_services_, and then if you're a sadist, you could actually just parse all the JSON structures inside that environment variable. But why? Just use the cloud environment API. And because it is doing something fundamentally cheap, I, to my shame, feel no problems or, I have no problems in just recreating it. This is sloppy code. You're absolutely right. I should have put it somewhere. It doesn't have any lifecycle. It's just, you can say, you saw it yesterday. Adrian created, he had Boolean is Cloud Foundry equals new cloud environment dot is Cloud Foundry. He created the object solely to be able to get access to that Boolean and then threw it away. Right. So I'm also doing some black magic and sorcery here to initialize a data source, right? This is just for the posterity. It's for the demo itself. Obviously, you're going to have a different scenario. This is the equivalent of the JDBC :embedded -database schema. You use it, you pass in a SQL script and pass into a pointer to the data source, and it'll go ahead and run the SQL for you as the Spring application starts up. So this is a good way of ensuring that you have consistent tables and so on. You can run DDL to delete stuff and whatever. Obviously, keep that particular bit in maybe your development profile. You don't want that thing running in production and drop tabling all your data in production. This is the Java API equivalent of that, right? Okay. And now here's the stuff that is Spring Batch infrastructure specific. I mentioned Spring Batch saves state, right? Well, where does it save its state? It saves it in a database. So if you want to actually run the data and you want to actually work with Spring Batch, you need to tell it where it can store everything, right? So it's going to run those jobs. It may go for a week. The job might be, you might kill -9 the Java process. Then what? What happens to your job process and your job state? It's all still there. It's all safe. It's all tucked away very neatly and succinctly inside of a database, which you as an operator can audit if you like, or you can interrogate using those Java APIs that we've seen. That's why Spring Batch can do things like retry jobs that have failed, because it knows where things failed, it knows how far things got, and so on. That's why Spring Batch can do things like restart jobs, etc. Right? So this is very, very powerful. It needs state to do that. So you need this class because it basically tells Spring about job registries. You need a platform transaction manager to work with transactions talking to the database, no big deal. You need a job registry itself. In this case, we're using an in-memory map. You need the job repository. The job repository is it's the runtime facade to all that back-end database state. So it's the guy that needs the data source and the transaction manager. And we create that. You need the job launcher itself. Remember before I had a reference to a job launcher? Well, the default one is simple job launcher. I'm creating it and I'm passing in a reference to job repository. We need a REST template since we're going to be talking to REST at some point. And here are some classes, and this is the meat of what we're going to be doing here. This job is simply a batchified version of something that connects to a web service to get stock information based on ticker symbols. And the class, the code itself, is this guy. I created 3 implementations for demo posterity, right? You never know when one web API or web service will screw your demo up. So always have backups. I've got a mock version here, a Google Finance version, and a Yahoo Pipes version. All of them they serve the sole purpose of providing me stock data, even if it's just fake stock data in some cases. Yahoo Pipes, how many of you guys know what Yahoo Pipes is? Pretty, marginally. I mean, it's easy to marginalize it, but it's actually pretty cool. They actually have this really, you should, if you get a chance, just sit there. You can create connections between web feeds, so Atom, REST, whatever, and you can say, I want to pipe this feed in some other conduit and have it transformed, and then I want the result as a feed itself. So in this case, I'm actually using Yahoo Pipes. Let's see. Using Yahoo Pipes to hit this query API here, this long URL. And when I get the information back, I do all this nasty stuff to parse the JSON structures and extract stock information, right? And the result is I can say, hey, look up the stock symbol for VMW and give me the information based on right now. I want a moment in time snapshot of what the stock looks like. So you can imagine this would be very useful for end-of-day jobs that process stocks or whatever, something like that. Okay, so questions? Yeah. Yeah, I recommend it. You don't have to. No, I think there's an in-memory version. But taking a look at that, fair question. Let's see. Let's see, bin. Coffee time. Hello. No, this is an H2 connection locally, just so I can, for posterity, although I wonder, grep Java. We are annoyed. Oh, whatever. Let me walk through the code and then we'll actually show you the tables so you can actually get a feel for that. I'll show you in Postgres because that one works. No, please, yeah. Data source. Back over here. So remember, what I had is I have a couple configuration classes. In Spring Java configuration, you create a Java configuration class and you annotate it as appropriate. Here I've just got a Java configuration class. When you see a class with @configuration on it, look at that and go, oh, that's the same as the Spring XML file. It maps almost one-to-one. And when Spring sees that, it's going to go through and see any methods that have @bean, and it's going to interpret that in the same way it would an XML element with the bean tag, right? The class that it creates is going to be of the return type. The bean ID is going to be the method name. and then the life cycle will be handled and all that stuff. So what I'm doing is I've got a configuration class, and I'm importing, or in this case just injecting, I'm importing another XML file, or in this case just another Java config. The Java config class is the one that provides the data source reference.
Where did you say pull this data source from Cloud Foundry?
Well, so remember, I have two implementations of this class. This is an interface that I created, and its sole task is to have two implementations, each one in a different profile. So the local version, as you saw, is just H2 in memory right there. And then the cloud version is this one right here, where I'm using the cloud environment, and I'm saying, give me all the relational database information, and then give me a working pointer to a data source. That's this guy here.
So where did you say go pull the Cloud Foundry, go pull something from Cloud Foundry?
This right here.
Just by saying this cloud environment?
Well, I'm asking cloud. So remember, this assumes that you're running inside of Cloud Foundry. First of all, you can't. This doesn't work if you're running locally. It doesn't connect to Cloud Foundry. If you're in Cloud Foundry, however, what this will do is it'll give you a collection of objects of type RDBMS service info. RDBMS service info itself. That's not. You don't want to look at that. RDBMS service info itself can be used to ask about how many different data sources or Mongo databases or Redis instances or RabbitMQ instances are bound to your application. So you can provision a data source and then create an instance and then pull it, right? You can say, I want to create, if you have one bound, go ahead and hydrate or inflate a working, valid connection to that database. I don't care about what the username and password are, right? The cloud knows, I don't know, I don't care. I just know that it's bound to my application, and this API will enumerate all the relational databases and give me a working instance of a data source, independent of where the database lives, which port, which IP, which username, which password, which schema, right? So I didn't have to hard code any of that. The cloud knows. And you can actually look up the cloud. You can look up the database instance by database name as well. You can say, I want the stocks database. But since in my situation, I'm just assuming that there's just one database, there's no need, right? I'm only assuming there's one database. So I just want that one, whatever that is. Does that help or no?
Yeah.
Any other questions on that? I know I'm taking for granted a lot. This is more of the slightly medium.
In this app, you don't have to define anywhere what databases are sitting on Cloud Foundry.
You do that as a part of your Cloud Foundry management, and we'll look at that in just a second. Actually, so we'll get to that in a second. I just wanted to give you guys a lay of the land of the code here. So what do we have? We have a batch configuration class. It defines the batch infrastructure, like the job repository. The job repository in turn needs a data source. That data source is unique to each environment in which it runs. Naturally, I've extracted that out into another configuration class, and those configuration classes have profiles, right? We're missing one final piece. We've seen how you launch it. We've seen the different, let's see, we actually haven't seen all that. We haven't seen this bit right here. So, job repository. I've got my own reader here, right? I haven't written my own, but I'm configuring an item reader to get information from the database. What it's going to do is it's going to go through a table called stocks, and it's going to get all the symbols in that table and read them. And then I'm going to configure a JDBC cursor item reader. The item reader is going to execute this SQL for me. It's going to use this row mapper. This is a JDBC template ism, right? You know the JDBC template. You can say JDBC template.execute. You pass in a row mapper. It gives you a pointer to the row and the row number, and then you have the chance to transform it, update it, work with it, whatever. In this case, I'm extracting the symbol column. So for every row in the result set, I want the symbol column, and I want that string. And I'm going to use that. And this item reader, what it's going to do is it's going to read in strings. It's going to read in the symbols for me from that table. Once I get that symbol, I want to process it, right? So I'm going to create my own item processor here. The item processor takes in the string that we get from the reader, and it returns an object of type stock symbol lookup, right? So we get to do a little bit of transformation here. So I'm saying item processor, and I'm just returning an anonymous inline one because it's dead simple. I don't need to create another class. And I use my little Yahoo Pipes-based client to look up the symbol. And the symbol is of type stock symbol lookup, right? So the item processor receives the strings from the table, does the lookup, and it returns an object. That, in turn, gets forwarded to this JDBC batch item writer. markedly more complex writer. So, for example, here's the item writer. I'm configuring the JDBC batch item writer instance that comes with Spring Batch. I don't want to have to write this logic myself, so just let it do it. I'm saying I want you, I want you, JDBC batch item writer, to work with stock symbol lookups, which came from the processor. I want you to use this SQL. So insert into stocks data, blah, 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 and I've got the named parameters here, DA, HP, LP, whatever, typical JDBC stuff. I'm setting the item SQL parameter source provider, which is basically the object that we use to map name parameters to values. So given a reference to the stock symbol lookup object, this object will create the named parameters for the JDBC statement, right? So I'm going to write data into another table based on the lookup results of that web service. And this is how I'm doing it, right? This is a lot of code in one place. I get it's kind of gnarly, but basically pretty simple. The only part that we care about is taking those stock symbol lookups and writing them to a database. We don't even care about writing that. We just care about telling the machine which parts it should write to the database. And this is our chance, this one little stanza right there where we're sending the item SQL parameter source provider. We're saying, given a stock symbol lookup, here's the mapping of values to name parameters. That's all you care about. The rest of it is just, you're just configuring stuff. I'm setting up SQL statements, I'm setting up all that. The only thing that's of note, of merit, of whatever, this is kind of mind-bending. How many of you have used Spring's notion of scopes? So cool. So Spring has, by default, 2 scopes. Since day one, it's had 2 scopes. It's got singleton and prototype, right? So you create a bean, and the bean, when you inject it, is either going to be a shared reference that's unique to the entire application context, or it's going to be a brand new instance every time, which is less and less useful these days, but it's still an option. And at one point in Spring 2.0, they introduced this idea of scopes. You can provide your own scopes. So for example, I work on a project called Activity. Activity is a workflow engine. In the workflow, you want to be able to say that this is a object that is scoped to this workflow process. So if I have 2 processes and they both inject a reference to this object, there's 2 different references. But it's the same object within the process. So if the process goes on for a year, and I inject that reference, I always get the same instance that was created back in the beginning of the process. It doesn't get recreated. When you use Spring's web support, you can say that this object is web scoped. It's request scoped or session scoped. So you can say whenever a brand new HTTP request comes in, create a new instance and inject it for me. It'll be unique to my controller, my Spring MVC controller. I'm getting a thread, basically I'm getting a request local object. We actually have a thread local scope. So you can actually configure that. It'll create an object that, if you inject it in a different thread, is going to be a different object. So if you do @inject, foo, and you launch that, you do that in 10 different classes, which are random threads, they'll always be unique. They won't be shared across threads, right? So this is a very useful feature. It's declarative, right? You do the scoping and all that stuff in the configuration, and then for you just inject it and it does the right thing. You get new instances. And this is useful in the case of Spring Batch. Spring Batch has jobs. The jobs have steps. And you want unique data per job and per step. So we have a scope called step. And so, for example, because I don't want other threads and other steps to share my item writer, right? This is something that definitely has a lot of state to it. This is an object that'll go through my records and write data to a database. I can't share that. This is not to be shared. It is very much state aware. It knows where I am relative to the record set and so on, right? So I've scoped it to step, okay? And the other nice benefit of that is, because my writer needs a job parameter. Remember I showed you guys those job parameter map back at the beginning where we looked at the public static void main? I've said, I've got this, sorry, where did it go? Here we are. This guy here, I'm creating a date. I'm creating a job parameter, and I'm adding a date, and it's got a value. And this is very common. You might have a job that runs every day at midnight. So each job is unique. Why is it unique? Because the date is unique. So you can say this is the job that ran at 5 p.m. or whatever, in the back. How are we doing for time, guys? 15 minutes. Good gravy. Okay, we got to hurry. So the point is, you have data that's unique to each scope. Very, very powerful. Okay, let's see. So the point is, back here, I want this date parameter I want the unique date per my job, right? Remember, Spring is used to configuring objects, and then you inject the reference to the object based on the scope. But I also want values that are unique to the scope. So here I'm saying, for every unique job, I want the date that was given to me there. And that's what I'm doing here. I'm injecting a value, job parameters, date, and I'm getting the date. And I can use that to uniquely insert SQL and so on. Okay, so let's do that first. Oh boy. Can't believe we're almost out of time. We may be a little long, guys, but don't fear. It is good. Okay. No problem. So, okay. So this is my code. I'm going to go to the first one here is the batch code. I'm going to do this. I'm going to do VMC push. Again, the nice part about having the manifest is I don't have to really specify everything else. This is going to deploy a job to Cloud Foundry called batch, and this is why when you guys check out the code, change the application name so that it's not stock batch, because it'll be I will already have taken it by obviously. But then once you've done that, just do VMC push. So made this guy. You change this part right here. That's all. Just change it to your name or whatever, and then it'll be deployed. So I've deployed the application, VMC apps. It's running as a background job on Cloud Foundry. It in turn is connected to this service called stock batch. So I'm going to do a VMC tunnel. Whoops, VMC tunnel, and I want to ask VMC to connect to stock batch, please. Now remember, this thing runs every 10 seconds. It's still running. It's kind of a brain dead job. You should probably use a cron expression and have it run every night or whatever, but for demos, you know. So we're going to go ahead and use the tunnel. It's going to punch a hole in the cloud and let us connect to the remote data source as though we're running locally, right? So in this case, it's dumped us here at the console, and it's given us a username and password and a schema name. We can use that information in any client you like, be it command line or visual, Toad or pgadmin or whatever. But this particular tool goes one step further. It's a very, 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 very friendly tool. I think it's the most friendly of all the Unix command line tools in the whole world, because not only has it set up a proxy, a tunnel for us to our remote data source, but it has offered to start up the client for us, which I think is great. I mean, imagine if everything else worked like that. Imagine if you were petting a cat, and then when you're done petting the cat, it went out and found you another cat to pet, you know? This is a very, very friendly tool. So, number 2. So we're logged into the database here. I can interrogate everything. So these are the job execution state tables that Spring Batch needs. So you can see batch job execution in context, whatever, batch job params. And then our 2 tables are at the bottom there. So I've got stocks. That's the one we read data from. So I've got 4 stocks that I want to, or 5 stocks I want to be read every day at the end of day. And then I go from, and you can see it's chugging along, getting the end of day prices, you know, the prices as we have them. Of course, it's been running now in perpetuity since we launched it a couple minutes ago or a minute ago, so we've got a lot of extra data. But that's what it's doing, right? So this is a very natural use case. You can just put it in the cloud, man. I mean, you don't need to worry about this stuff anymore. You've taken care of a whole batch job, and it's no longer your problem. Spring Batch takes care of the scheduling and the hard work. Cloud Foundry takes care of the hardware and the management. Okay, so moving on very quickly. VMC stop batch. I'm going to stop this application because I don't want it to continue spiraling out of control, creating records. Okay, moving on. Application integration in the cloud, Spring integration, right? How many of you guys have done enterprise application integration of some sort? Okay, yeah, me too. Pain, right? I mean, I've used Axway Integrator, Web Methods, and Tibco. We've all been bruised, and I've used the Numerid open source solutions. And they kind of suck, but not Spring integration, right? Spring integration, it's near and dear to my heart. It's very simple. And integration, if we're honest, is everywhere. It's more common than you think, right? So look at system A, look at system B, and look at the connecting channel, right? You don't want to reinvent the wheel in integration. Very important. Same with batch, but even more so in integration, because integration's hard. So let somebody else do it, and you just write the code that works with it, right? Don't reinvent the wheel. Don't do it yourself either, because it's very common with integration problems to see these sort of bespoke architectures of fragile stuff, like where things just fall apart because it's duct tape and baling wire and dead souls, and it's just horrible. Don't do it. You can do better. Let the integration engine do the hard work. This is a Rube Goldberg machine. If you haven't seen the Mythbusters episode about Rube Goldberg machines, do. As I mentioned, this all stems from the Enterprise Integration Patterns book by Bobby Wolf and Gregor Hope. Great stuff. Spring integration itself is very simple. You have channels. The channels are the communication mechanism between components. The components themselves do the work. Components that sit at either at terminus, the beginning or the end of a process, are called adapters or gateways. They adapt an external system, JMS or databases or whatever, to their messaging system. So they take in a record from the outside world, convert it to a message, and then you can deal with it in terms of channels and pipes inside of Spring integration, and then you write it out to the other side. Very similar to Spring Batch, except it's more event-driven instead, right? We'll skip the primer. One nice feature of Spring integration is that it lets you hide the messaging system behind a facade, a gateway. And again, if you've read that book, then you'll recognize the common API idioms inside of Spring integration as being one-to-one. The documentation for Spring integration is that book. If you understand integration, you understand Spring integration. It works very nicely. So here I've got a typical service class. I've omitted the body, but you can imagine writing this code. Maybe you probably would have written a unit test and so on, but it would have been kind of like this, right? I've got a customer service object whose charge is to add a customer record. I want to solve this problem, but I want to solve it with messaging. So one option is I can inject a reference to a message channel and a messaging operations instance from Spring integration, and I can say operation send and receive on this channel, send a new customer, build it, and then off we go, right? And then that'll get sent to some external system, which will actually write the record to a data store of some sort. Or I can create an interface, which is what this should be, and add at gateway. And Spring integration it'll create a reference that I can use of that service. So I can say, here's my customer service. Go ahead and give me a proxy object that in turn talks to the messaging system. It knows about channels. It knows about inbound and outbound. So let's look at that right now. And that's what's really powerful here as well. This is what I meant when we talk about creating decoupled architectures. Here's my service. Again, this is going to use the same stock symbol lookup thing we've got before. We don't need that. Actually, I wonder if yeah, good. So here's the class, right? Very simple class. It's a client. I'm not going to use this client, but you can see it's the same basic thing. The service configuration itself looks like this. I'm injecting reference to RabbitMQ. I've got a REST template. I've got my Yahoo Pipes instance, Rabbit Transaction Manager, a message converter to convert objects to JSON, and I'm declaring all the stuff that you need for communicating over RabbitMQ here. And then more saliently, I've got my actual Spring integration design. You can see here we've got this pretty little designer view that you can use from inside of STS. It's nice, it really is, but you don't need this. This is not TIBCO. You don't actually need a visual drag and drool tool to do useful things. The XSD is quite approachable. So here's the basic arrangement, right? Whenever a message comes in from the ticker, go ahead and pass it to my Java client called client, and I'll do some work with it, and then send the reply. Right, so whenever the message comes in to this client, I'm going to look up the stock symbol and then send the reply back out on RabbitMQ. Yeah, so very, very simple. Inbound gateway implies that I'm going to take a message in, do some work, and then it's going to expect to send a reply back to the connector, to the client, synchronous, right? But I don't want to have all that code in my client, right? So what I've got now in the client, in the web client side, on the web application, is I've got this gateway, stock client gateway, stop symbol lookup string table, and I've configured my client XML here, and it's got a Spring integration gateway object. So I'm saying gateway service interface, and I'm passing in the reference to that interface class there, and I'm saying the requests, the input parameters, the method arguments should come from this channel, and the replies, the return values of the method should go to this channel. See what I'm saying? So when a message comes in, it gets converted and passed into this method as the argument. And when a reply is created by this method, it's sent out on the reply channel, right? So the client perspective is that of this synchronous interface. But what's actually happening is it's sending messages over AMQP, waiting for that other job we just looked at to look up the stock symbol and send a reply. When the reply comes back in, this code returns the value that it got from that messaging system, but you don't have to care about that. As far as you're concerned, it just looks like an interface. Okay, so not really a lot to look at there. Let's actually go ahead and deploy it and see what we get. So CF workers integration web service. Okay. VMC push, absolutely. Would I like to deploy from current directory? You bet your sweet bippy I would. This is going to declare a stock RabbitMQ instance for me. It's going to provision the application and provision the RabbitMQ connection for me. I'll deploy, okay, and then go back to the client, CD, CF workers, integration web client. Hello, VMC push. Deploy from the current directory, you bet. So we have two different systems here. Remember, they're insulated from each other because they're decoupled by the RabbitMQ broker, right? Okay. And this is good because if we wanted to, if we got a lot of load, if say for example our web application was inundated, if say the web application was on Oprah, you know how things go when you get Oprah or Slashdot or whatever, right? If the web application is suddenly inundated, you simply add more. You do VMC instances plus 10, and then you pass in the name of the app that you want to scale out. In this case, we want to scale out the service. The service is the thing that consumes messages from the queue, calls the web service, and then returns a reply. Right? That's the thing that'll get overloaded. So now you've decoupled the load of the service from the web application itself. You don't have to deploy new web applications to scale this. And it works just transparently, like you saw in the keynote. You just add more clients, they consume more messages faster, and they send more replies. And the web application is none the wiser. So apps. I've got my two apps running. My web application is running over here on integration web client dot whatever. Okay, so I can look up, I can do a, So this is looking up stock data live. It's going over the message queue, going to the other node, getting the stock information, and then sending a reply, right? So this is a very, very powerful way of actually, you can build scalable services. It's very clean, it's very succinct, and you don't have to pay the cost inside the web tier. You don't have to have all that logic there. Okay. Okay, yeah, so conclusion. RabbitMQ, awesome. Web scale messaging, awesome. Cloud scale messaging. Batman doesn't agree, but it's still awesome. Spring integration makes AMQP and messaging very, very, very simple. It builds on top of the primitives that Spring Core provides for AMQP and JMS. Spring Batch itself is a very important thing to solve. It works very nicely on top of RabbitMQ and in the cloud. And that's it. Questions? How do we do for time, first of all? Yes. 2 minutes, guys. Awesome. Okay. I will take 2 minutes of your questions, and then we have to leave, and you're more than welcome to send me an email at, boy. Here we are, Josh. Take this down if you have questions. It's very important. Okay. So, yeah. Anything. You must have some questions. We talked about a lot today. Rabbit, integration, batch, workers, Cloud Foundry. Anything? Feedback? Tomatoes? Where do you guys even get those tomatoes? Yeah. Whoa. I'm so sorry. What? Oh, github.com, github.com/Cloud Foundry, one word, -samples. And then there you'll find a whole bunch of different things. This is particularly, it's a project called stock-workers. And the blog version of this talk, let's see, Workers, Cloud Foundry, Spring, okay, is this guy right here. So blog.springsource.org, put it up, it was published in May of this year, so it's basically, it runs through the same code and kind of introduces some of the same ideas. Yeah, okay, whoops. Other questions? Okay, guys. Well, thank you, and feel free to reach out to me. I hope you have a good show and enjoy the balance of your time here.